So Janab, I received the problems. Okay. So from next class onward, we'll do the problems also. Whatever the
No
problem you
problem,
see.
sir. Sure.
Okay. So what we are going to do now, here you see, we are going to study some different law today. Okay. So whatever the law we are going to study, here we are going to Hess law. We are going to study the Hess law. Hess law. This name is again one more is there, or this is also called Hess law of constant heat summation. Hess law of constant heat summation. Acha, this is the only
Okay,
toughest
sir.
topic on the, on the basis of this, only the tough question they ask on the basis of this only. There is no other topic in this chapter which can be as difficult as this. Okay. So this is the every year the NEET problem comes on this topic. Every year there is no years left that problem they are not giving on the Hess law. Okay, because Hess law applied on the so many things. It is applied on so many things, not the only one thing. So first of all, summation means sum. Simply summation means the sum.
Yes,
They
sir.
are saying what they are saying, that is change in enthalpy. Change in enthalpy. We can say change in enthalpy is always, it is going to be change in enthalpy is always same whether the reaction is taking place, whether the reaction is taking place. How they are taking place? They are saying taking place in single step, place in single step or multiple step, in single step
Yes, sir.
or multiple step. They are talking like that, multiple step. So if any reaction is getting carried out in the one step, that the enthalpy change will be something. Then if it is
Yes, sir.
taking place in the multiple step, so that is sum will be always the constant. Let us try to understand. Suppose I am having the one reaction is there A to B. So anything it is converting into A to B, and it is the single step. They are talking about it is the single step. So single step is they are saying that is enthalpy of reaction is there, Rxn. So they are saying that is one possibility is there. Okay, what the possibility is there? You can go in the multiple step. So how the multiple steps it can be? Suppose it can be A to C it is going, then it is converting into C to D, then it is converting into D to E, and finally it is converting into the B. That can be multiple step also. Okay, that I will explain.
Sir, why not we convert E to B? Why not A to B?
So this is multiple step, na? Multiple step.
Okay.
Okay, wait. I'm explaining you. See, suppose I need to go C to CO2. If I am adding C carbon plus oxygen, you please keep on asking the doubt. Now it will be very much good for us to understand. C plus O2, it is going to be CO2. Okay, so this is the completely carbon dioxide is giving. It is the single step. This is the single step. Some energy will be there. So suppose delta H R X and reaction is there. So single step. If I am going multiple step also we can go. How we can go multiple step, that I am explaining you here. Say multiple step. So C plus half O2. C plus half O2. So 2 cancel out. So C plus O2 it is going to be CO. So enthalpy release is delta H1. Then it is also possible CO. We can take CO plus again we can take that is half O2. So what it is going to give,
Yes, sir.
2 will be cancelled out, but oxygen will left. So it is going to be CO2. So this is delta H2. See, so that is, this is the single step process. Yes, yeah, no. This is the single step.
Yes,
CO2 is
sir.
forming. And here this is the CO2 is forming. We are going for the CO2
Yes, sir.
only CO2, but it is converting into CO2 by 2 steps. Firstly, CO, it is converting CO, then CO is converting into CO2. Yes, yeah, no.
Yes, sir.
Okay, good. So see, so apply Hess law. If we will apply Hess law, so they are saying ki single single step, they are saying single step is equal to sum of multiple steps. Sum of multiple steps. This is what
Yes,
summation,
sir.
sum of multiple steps. It means delta H R X N is equal to, that is delta H1 plus delta H2. Getting my point?
Yes, sir.
Okay. So again, come back to the first page. So suppose this is the enthalpy of reaction is there for A to be direct single step. It is the multiple step. So it can be that is delta H1, delta H2. This is 1, 2. This will delta H3 and delta H4. Okay. So apply what they are saying.
Yes, sir.
Change in, they are saying change in enthalpy is always same whether the reaction is taking place in single step or multiple step. So they are saying that the enthalpy of reaction, they are, again you read, change in enthalpy of enthalpy is always same whether the reaction is taking place in single step or multiple step. So single step is the this one and multiple step, this is sum of this one. So according to Hess law, so if you are going according to Hess law, so what will be there, Janab? What will be this? If they are saying that is single step, enthalpy in single step. Here we are writing enthalpy in single step. Enthalpy in single step is equal to enthalpy in multiple step. No, enthalpy in multiple step. Enthalpy in multiple step. So okay, sum of enthalpy in
Sir.
multiple step. So this is what the rule is. According to which rule they are talking about? They are talking about according to rule of Hess law. So what we can do here, you can see that enthalpy in single step means delta H R X N. This is going to be enthalpy of reaction. And this side, if you are going to, this is going to be delta H1 plus delta H2 plus delta H3 plus delta H4. Can you be, please, can you understand this one, please?
Yes, sir.
Okay, great. So can you make a note of it?
Yes, sir. Making.
Hmm.
Done, sir.
Okay, thank you. So here I have given you one example. So this example is okay. I think it will be okay to you to understand this example. Yes or no?
Yes, sir.
Okay.
Yes.
Okay. So what we are going to do, we are going to solve some of the problems here.
Yes, sir. I'm writing this.
Okay. Yeah. But I'm giving you the problem also on the basis of it. Okay.
Sir,
Hmm.
I wrote this. Sir, means like you teach NEET students also, na, sir?
Uh-huh.
Excuse me, sir.
Yes, yes, yes. Audible?
Yes,
Not
sir.
audible.
You teach NEET students also, na? So,
Yes, yes.
sir, can you just say some books to refer? Means like, sir, material kind of.
Material. Like you said, na, so you are having that is Sri Chaitanya already there, na? Sri Chaitanya.
Yes, sir.
Okay.
But sir, in that means like for other subjects.
Okay. Wait, Janab, your
Yeah.
voice is cutting, I think. Network issue is there. I'm
Now,
opening
sir.
the now okay. From my side, is little network issue is there. Wait. I'm opening the
Yes, sir.
Windows. Maybe it will be better. Yeah, it may be now okay. Huh. So books, if you want to, Janab, that is one book I am writing here. A to Z is there. A to Z. A to Z chemistry is there. This is quite good book. A to Z chemistry. This is the Singage
Means
book.
like, sir, for NEET preparation, as per NEET preparation, I want.
Yes. This is only for NEET only. This is coming in the both book NEET and JEE. You have to purchase only for NEET. So this is the A to Z chemistry. Singage, Cengase. I'll share you. I'll go. Now I am in the relative house. When I will go to my room, I will
Okay,
take the
sir.
book and I'll send you.
Okay, wait, sir.
Hmm.
Okay, and sir, means like for, can you say for physics, chemistry, botany, zoology also, sir, please? For sir, NEET preparation, I want. IP, I can do.
Okay, so NEET one, Janab, this is the easy one. This is the problem is there now. What is the this one? The same book, same publication is coming. What the good thing is there in this book? Like suppose I am teaching you Hesla, na? So on the basis of Hesla, they have given the certain questions.
Yes, sir.
Then some other law you are studying, then
No,
again
no,
they are
sir.
giving. Hmm.
Like, sir, in like physics you take. Okay, example, sir, I'm giving because I'm weak, a bit weak in physics, sir. So
Okay.
I'm giving example. So, sir, means like now I feel weak, or else first I used to get very nice marks. Now chapters means like I'm not getting a bit.
Okay.
So, sir, like for means like explanation जो है था, right, sir? Means like the explanation of a certain topic. Oh, means like it should be easy and all. In my material, very complicated language, sir. I cannot understand.
Then do you have this one Pradeep publication? Pradeep.
No, sir, I don't have anything. That's why I'm
Pradeep.
asking you.
This one is then you can purchase, but it is very heavy book. You don't have time this much to read out the Pradeep publication.
Sir, look, sir, if I want to means like achieve something, I should take out some time. I'll manage the time. But sir, if it is it nice means like for learning and all. Of
This
course,
is
sir, I
it.
need similar one for botany zoology also, sir. If you can say, can you please say, sir? Means like if you can say which
This
books are
Pradeep publication.
for good for.
This is
Okay.
Pradeep publication. This is going to be very easy language. Easy language.
Okay, sir.
Hmm. This is the very easy
Okay,
language.
sir.
Hmm. Pradeep
Yeah, sir.
publication.
Because it's getting very means like it's getting very how to say it's getting very hard, sir. Means like to understand from material according to NEET preparation, it's getting very hard now. So that's why, sir, I'm not able to understand. That's why I said you, sir. Means
Okay,
like
okay.
chemistry, you are making me understand that's getting easy, but now physics is getting tough. So I said you.
Okay. No, in the physics, if you are
Okay, sir.
facing too much problem in the physics, you let me know some of the chapter. Any 1-2 chapter I can deal you in the better way. Okay. So any Sunday,
Okay, sir.
Sunday you take out the time and let me know that is which chapter you are facing problem in physics. On the Sunday I will explain
Okay,
you.
sir.
Okay.
Yes, sure, sir.
Hmm. And for the case of chemistry will make you perfect in chemistry. Whenever you are next day
Okay.
you are going to write now, so that is chemistry is my responsibility. So don't worry for chemistry.
Okay. Sure,
Mhm.
sir.
Okay. So chemistry, you don't worry. Slowly you try to be in the rhythm, and from next day
Okay.
onward, I'll solve some problem. I'll send to you also.
Okay, sir.
Mhm. So let's try to go for the one more problem. I'm writing the problem question. They are saying prove the prove the given reaction. Prove the given reaction
Mm.
is following Hess law. Is following. They are saying Hess law. Hess law. They are asking that is the given reaction is following Hess law or not. So here they are saying that is the uh, C plus O2. C plus O2. They are giving it is CO2 and they are talking about this is the delta RH. Okay. Enthalpy of reaction, and here is not. Not means standard state. Means temperature pressure is 180 atmosphere STP. If there is zero on anyone is there, na, so this is they are saying standard state. Means temperature is
Yes, sir.
temperature 25-degree, pressure is 1 atm. So if anything is standard like that they have written, so that is pressure is 1 atm. This is going to be 1 atm. Temperature is 25 degrees Celsius. These things they are talking. So delta RH they are saying here they have given 393.5 kilojoule per mole. They are talking about. Okay. Now they are talking about one more reaction they have given, C plus half O2. C plus half O2. This is the method one. They have said the method one, and here you can see that is method two. This is method two.
Yes.
C plus half O2. If you are going, this is going 2 will be cancel out. So it is going CO and delta R H1 naught. They are talking about, they are saying 110.5 kilojoule per mole. This is the point. Second one, they are saying CO plus half O2. CO plus half O2. So it is the giving CO2 because these two and these two cancel out. So 2 oxygen, CO2. Delta RH2 naught. It is going to give what 283.0. They are saying kilojoule per mole. Okay. So
Yes, sir.
A number option they are saying S according to Hess law. B number option they are saying no. C number they are saying can't be determined. Can't be determined. Can't
Yes,
be
sir.
determined. Determined. A D number they are saying incomplete statement. Incomplete statement. Statement.
Yes, sir.
So Janab, this is C, the direct we are doing here. So if you see this question, this is the product is being formed in the single step. Carbon when
Yes.
oxidized, so this convert into carbon dioxide only. And here you see, this is firstly converting into carbon monoxide, then carbon dioxide. So this is again getting formed, that is CO2, but this is going to be the double 2 steps. This is 2 step. So that is what if you are
Yes.
talking about solution. So solution they are saying according to Hess law. According to it is going to be Hess law. So what you are going to get that is enthalpy in single step. You can write here enthalpy. If you are talking about enthalpy in single step, you can write single step is equal to sum of enthalpy in multiple step. Enthalpy in multiple step. Sum of enthalpy in multiple step. They are saying this should be equal. So enthalpy in single step they have said here minus 393.5. Okay, this is what kilojoule per mole. This is kilojoule per mole equal to, here you see multiple step. So that is we have to add now because delta HRXN is equal to, I told you, delta H1 plus delta H2. This is the Hess law. So what we are going to do, we are going to add it out. These two we are going to add. So 393.5 if you are adding, so here you are getting 110.5 and then plus it is
Yes.
again in bracket minus 283.0. So plus into minus, that is going to be minus. So here is 393.5 equal to minus 110.5 and plus into
Yes, sir.
minus 283. So what is there here? You see 393.5 minus this side also I think same will come 0.5, that is here is the 0.5 and this is the 3 and 8 and 1, that is 9, 213, 393.
Yes, sir.
So these all are same, yes or no?
Yes, sir.
So they are following, this is going to follow, yes or no? Follows.
Yes, sir.
So it is follows Hess law, means option number one is this is correct, option number one. Can't you understand this?
Yes, sir, I can.
Okay. So if you can make a note of it, that will be much better. I'm taking the pic also. I'll share you.
Yes, sir.
Okay. If it is done, you tell me. So I will go on the next problem.
Okay, sir, I'll share.
Okay. Done?
1 second, sir.
Mhm.
Yes, sir, done.
Okay. So now we are going to solve the tough problem. Okay, this is the ask that neat problem we are going to solve. See the tough
Okay,
problem
sir.
and going for the long method. Firstly, we are going for the long method. So question is there. They are saying calculate. If you are talking about enthalpy of formation is there. Okay. One more is there. Direct equation is there. So enthalpy of formation. First of all, let us try to understand enthalpy of formation. Enthalpy of
Yes, sir.
formation. So what is concept enthalpy of formation? Enthalpy means energy. Enthalpy means energy. This is what. So whenever anything is enthalpy, so enthalpy is that is energy. But the energy means it is always supposed to be released. But enthalpy means it can be positive and negative. So enthalpy, if they are talking energy, enthalpy means energy absorbed. Okay, enthalpy means what? Energy absorbed or energy release. For both term, what is called energy enthalpy is used for both term.
Yes.
So enthalpy of formation. Let us try to understand enthalpy of formation. So that is the change in. They are saying the. You can write in the different one. The heat change. The heat change when 1 mole of the heat change when 1 mole of product 1 mole of product is formed. 1 mole of product is formed from its. They are talking about from its elemental state. Okay, that we have to keep in mind from it elemental state. So that is the heat change when 1 mole of product is formed from its elemental state. Elemental state means if you are talking about the state from which it is formed. Okay, so that is what
Yes, sir.
much energy changed, heat change. That is what is known as enthalpy of formation. Okay, so they are saying how can you be able to calculate? So delta RHF. Okay, enthalpy of formation. So if you are talking about delta enthalpy of formation, so how can you be able to write? So they are saying that is delta H naught, okay, delta H naught F of product. of product minus delta HF, delta HF not reactant. This is what the point. So they are saying from the enthalpy change from the product minus reactant, we have to, one method is there, how to calculate change in enthalpy. So we have to subtract from the product minus reactant, because here you see the definition. What the definition is: the heat change when 1 mole of product is formed from its elemental state. So what we have to do, that is how much energy is getting released or absorbed from the reactant, formation of reactant and formation of product. F for formation, here is F means for formation. It means to calculate the energy change, you have to know that is how the product is being formed and how the reactant is formed. So from the both enthalpy change, we have to subtract, then we have to be able to understand enthalpy of formation. Let's see another one. If you are talking about enthalpy of combustion, same way, enthalpy of combustion. One example is there. So enthalpy of formation means enthalpy of combustion. How to calculate? So delta R H combustion means C is equal to what? So that is here. Okay, we'll be able to solve this one later on. Otherwise, you will confuse. Okay, because there is going to be minus product. It will be, first of all, we are going to understand this one. Okay, so don't write this. I'll give you time to write this one. Let's try to solve the some problem here. So if you see there, the question number 1 is there. Calculate enthalpy of formation of CH4 from following data. So they are saying calculate enthalpy of formation. Yeah, enthalpy of formation. In some book, it is also called, that is heat of formation of CH4. They are saying CH4 from following data. We have to use the from following data. Okay, from following data. Following data. Okay, so let us try to understand here. What are the data is there? C plus O2 is there. Similar questions are there, but here we have to be very much concentrated, because it is based on Hess law. C plus O2. So they are saying that is CO2. This is, and delta RH naught. They have given minus 393.5. This is the kilojoule per mole. Okay, so this is the point number 1 they are talking about. Now they are saying that this is the first one. Second one, what they are saying, H2 plus half O2. H2 plus half O2. So they are saying H2O liquid, H2O, and how much they are saying, minus 285.8 kilojoule per mole. Kilojoule per mole. Last one, you see, third data they have given. How much they have given? CH4 gas, CH4 gas plus 2O2 gas. This is there. If you are changing, this is the CO2, this is going to be gas, and plus 2H2O, this is going to be liquid. Okay. Now, for this one, they have given enthalpy. How much they have? Minus 890.3 kilojoule per mole. This is the point are there. That is what we have to keep in mind, Janam. One thing you have to see, the definition will have to be always in the mind. Okay, so they are saying elemental state. Elemental. Suppose you have to form the water molecule, formation of water. So formation of water, how to be? Formation of H2O. So elemental state means that is H2 plus half O2. That is what the element now. So this is going to be H2O. 2 will be cancelled out. Yes, Yanu. This is the now if you want to form the methane, C plus 2H2. Yes, Yanu. So it will give, that is CH4. Acha, formation of methane can be, that is so many ways are there. So many ways are there. What are the ways are there? You can see this one. This equation is there. So CO2 plus 2H2O. If you are talking about CO2 plus 2H2O, CO2 plus 2H2O. So it is formed from where? That is CH4 plus CH4 can be there. And then it can be, what it can be? O2. O2. How many O2? 2 to 4, 4 O2. So CO2 is can
Yes,
be
sir.
formed from the CH4 can be formed from the CO2 and H2O. CH4, this can be formed from the CO2 and H2O also. That you have to keep in mind. So there, but the definition is saying that is from elemental state. We have to go from this one, elemental state. Yes or no?
Yes, sir.
So elemental state are what? From which element? Acha, you if you are able to elemental state, what is the meaning of elemental state? Elemental state means from which they are saying from which product form, from which product form. Yes or no?
Yes, sir.
So this is what from which product form. Yes.
Yes, sir.
Okay. Good. Good. So let's see. Now see the data you see C plus O2 CO2. This is what data is there. We don't know because formation of me in
Yes.
calculate the formation of CH4 we need now. So how can we use these data? It's a very difficult, very complex process. So how can we use? So at least if today you are able to understand one problem, that will be also great one. Let's see what we can do for this one. Required reaction. First of all, we are going for required reaction. What can be the required reaction? Required reaction is C plus H2, 2H2. So it is going to give CH4. This is the single step, yes or no? This is single step, yes or no? One step, you are forming from the single step, yes? Can you say this one? With this single step, C plus 2H2. This is CH4. Will give ya na? Yes or no? Tell me. Audible? Audible now?
Audible.
Okay. So can you understand this one? Because this is the formation always study from the elemental state. What is the elemental state of methane, carbon and hydrogen? Yes or no? This will be the solid form. They have given this is the solid. Here is this is the solid. This is the gas. Here is the gas. This is the gas. This is the gas. Liquid. Here is the gas. 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 So they are saying this is the solid. It can be. This is the gas. Okay. This is the gas. So single step is this. So what is the multiple step? What is the multiple step? So that is we are using this equation. So from one. From one. So from one, you see, C plus O2 is there and CO2. So C we required the same way I'm writing. This is the
Yes, sir.
required reaction. This is according to the definition. Definition is saying we formation of 1 mole of compound from elemental state. So self knowledge. This is the self knowledge. Single step is self knowledge. We got this from the definition only. So from equation 1, carbon required in the required reaction, reactant side. So same reaction I'm writing. C plus O2, it is going to give CO2. Second reaction, hydrogen required which side? Reactant side. So I'm writing the same one. H2 plus half O2 is equal to, it is going to be what? H2O. Acha, see, Janab, one thing you please tell me. In the
Yes, sir.
single step, 2 hydrogen required. Here, how many hydrogen is there? Here is 2 mole.
Sir, here two
1 mole
only.
is there. So what we are going to do here, we are going to multiply by these 2. Yes or no? Then we can get na 2 because this is the required reaction. Question they are talking about, nothing they are saying. They are asking that is calculate enthalpy of formation of CH4. But data they have given was H2. In the data they have given H2, but required is 2H2. So we need to multiply. Yes or no?
Yes.
So here is 285.8 is there na. That also will be multiplied. Here whatever is there, that is no problem. 393.5 is there. Acha, let me the fourth one. You see the third data. This is the second equation. Here is a from second. Now you see from third. From third. So from third, what you will see? This CH4 is required reactant side or product side? Which side we required? Here in the given data, it is reactant side. but they are saying enthalpy of
Yes,
formation
yes.
of methane. We required product side, na?
Product side, sir.
So we are reversing this equation. Can we reverse? So we are reversing. If you reverse this equation, so CH4 will be on product side and 2O2 will be also on the product side. So here what will be there? This side. So here will be, that is CO2, and that will be what? 2H2O. Yes, this is the CO2 plus 2H2O. We reverse. So when you reverse this one, the sign also get reversed. So sign will be what? 890.3. Right? This get reversed. Yes or no? Yes or no? Why the sign gets reversed? Sign is positive. Earlier here negative. This become positive. So let us see. Up now, how many CO2? CO2 we don't require, H2O we don't require, CH4 required, 2O2 not required. So whatever not required, that we have to cancel out. Here I am telling you very in detail, but in the competition we do in very fast. Okay, so see, oxygen in the required reaction, oxygen not required. According to definition, oxygen is not required. So what we have to do? This O2 is one molecule. This O2 is what? This O2 is what? If you multiply by 2, one molecule will be also here. Yes, yeah, on the reactant side, 2 O2 molecule. See, if you multiply this one,
Yes, sir. Yes.
so it is there 1 by 2 O2 multiply by 2. These two cancel out. So O2 is there now. So this become what is? This is what is left? O2. And here is again O2. So O2 and O2 is cancel out. So this is O2 and O2, 2 O2. And 2O2 and here 2A2. So left side O2O2, right side AT O2O2. That is both are cancel out. Is it okay? Is it okay?
Yes, sir.
This is left side O2, 2 molecule, and this side right side 2 molecule O2 cancel out. Now see water molecule, because in the required reaction water is also not required. So H2O, how many are there? 2 H2O right left side. And here if you multiply this one, this is also H2O left right side. So H2O H2O cancel out. Yes or no? 2H2O, if you multiply this equation, so again it will be cancel out now. So this is left side, this is right side. Yes. Say yes or no.
Yes. I said yes.
So here, here is CO2 is there, and this CO2 also cancel out. So what is left in this reaction? You tell me what are the things which are left. Can you please tell me in this given data? What are things left? So carbon is left. Yes or no? Carbon left. Yes. Tell me.
Yes.
And hydrogen.
Yes, sir. Actually, the voice is.
Here network issue is there. I think in the I came here in the relative's house, so network issue is
Oh,
there.
sir, I'm replying.
Oh, sorry, sorry. I'm putting this outside the microphone.
Okay, sir.
Now, see, second point you see. So C is there, then here you see positive sign is there, right? So what we can do here, hydrogen you see, multiply by 2. So that is 2H2. Can you say 2H2? Because here multiplication is there, not 2. Yes or no? And here is CH4 is there. So you see, this is equal to required reaction. So now they are asking, that is delta RHF, they are asking enthalpy of formation of methane. So how, with the help of these three data, we can calculate. See, this is minus 393.5, and this is what is there. If you multiply this one, so how much is coming? 2 8 just 6, carry out 2 8 just 16, that is carry out 1, 2 5 just 10, 1 11, 2 8 just 16, 1 17, and 2 2 just 4 1 5, 571.6. And here this is negative, and here is the same one. What is there? Positive 890. Okay, it's option. I am telling you the option also they have given. A number option they have given how much? Minus 74. They are saying minus 74 kilojoule per mole. B number, they are saying minus 73.2. Minus 73.2. And this is the B number. If you are talking about C number, minus 76.2, and D number, they are saying none. So what we can do, you take this data and add, because this is the enthalpy of reaction. This will be equal to delta H1, H2, H3. Okay, 3 step. So Hess law, what they are saying, the single step must be equal to sum of the all the steps. So this is the 1 step, 2 step, 3 step. We are doing summing.
Sir, your voice is breaking, sir.
My voice is
Your
breaking.
voice.
Okay. Yeah, your network problem is there, na? Actually, network issue is little bit network issue is there. Okay, now is he? Is it okay? Audible? Audible?
Yes.
Okay, problem is there. Here itself, it is showing very slow network. It's showing the slow network. Okay, so here anyhow little bit managed. So if you are adding up some of here you see, so enthalpy of reaction delta RHF. Okay, enthalpy of reaction, what we can do here, we are summing one. So delta H1 plus delta H2 plus delta H3. So you add. So how much is coming? Delta H1 is how much? 393.5. Then H2 is how much coming? Plus is there, but the value is minus. So minus 571.6.
Yes.
And last one is positive is there. So how much? 890. Okay. So here you see minus 393.5 plus into minus, that is minus 571.6 plus 890. Can you please solve this one? Two values are negative. Try to solve it out.
Yes, sir. Okay, sir. Wait.
Okay. 393.5.
Mm,
This is the negative one. And then plus
negative,
571.
negative, positive. One,
No. It will be negative here. Addition will be like
one,
when you 5,
5.
hmm,
Yes, sir. Yes. 1, 5,
576.
1, 5,
9,
6, 9, 9, 965.1 plus minus, it is minus,
571.6.
and then 890 minus 890.
Okay.
Wait, sir.
5.8 multiplied
Hard to calculate.
571.6.
Wait, mama.
570.
0.
890.3 is there. Here is, wait, this is 0.3 we are missing, 0.3. And here is, what is there in this equation? 285.8. So, well,
Yes, sir.
571.6. I think something.
Yes, sir.
So if you add, wait, I'm doing here. So negative, if you are adding now, so 393.5, 393.5. Then again you are adding this one negative 571.6, 571.6. So it is coming how much negative? This value is coming, that is what this value is coming, minus 965.1. And here is what is there? 890. So here is plus 890. 890. So you add it out. So if you are adding 890, so how much? 75.1 is coming. Something it is coming 75, negative 75.1. This value they have given 75.1. So this is our required answer. None of these is coming.
Yes, sir.
Uh,
Yes, sir.
5.1. This is the 75.1. So this value is the
Mhm.
negative term value. Yeah. So correct option will be which one? Option number. This one will be there. Okay. 75 minus
Yes.
5.1. Here there none of this is there. 76.2 is there, but it is none of this. Little bit. So correct answer is there minus 751. 75.1. Can you please be able to understand? This is although it is the top problem, but
Yes,
okay.
sir.
So what you can do? Can you please make a note of it?
Yes, sir. Yes, I'm making.
Okay. Yeah, not today. Done.
No, sir. Wait.
Wait, okay, waiting. Completed?
Yeah, done, sir.
Okay. Can we do the one more problem? Can we do one more
Okay,
problem?
sir.
Okay. Okay. So 5 minutes.
Yes, sir.
5 minutes we can study more. So that one problem you can understand the. Okay, one more. Here what they are saying, Jana, that is question they are saying.
Yes, sir.
Calculate enthalpy of formation. Calculate enthalpy of formation of CO from following data. From following data. So they are talking about from the following data, we have to calculate the enthalpy of formation. Okay. So that is what the data they have given here. The first one, they are saying C plus O2. It is giving CO2. Okay. How much they are talking about here? Energy release 393.5. Then second equation they are saying CO plus. Okay. Half O2. CO plus half O2. CO, no. Okay, CO plus half O2. They are again giving CO2. And here this time they are saying 283.5. This much energy. A number of option they have given minus no, 110. This is the A number. Okay, and this is kilojoule per mole. And B number option they have given 210. C number option they have given minus 310, and D number option none. This is the none of these. None of these. So this is what the solution. Okay. So what the solution is all about? Can you please check this solution? Required reaction. Required reaction. So required reaction is always based on required reaction. If you talk about now, based on definition. Based on definition. What is definition? That is what definition. If you talk about the what is definition? Definition is formation of 1 mole of product from element. So formation of 1 mole of product. This is the CO. They are talking about CO. What is the element here? What is the element? Carbon can be solid, and plus what can be? Half O2 is required. So half of cancel out, the two cancel out, so one oxygen. This is what is required reaction, right? This is required. So required reaction always written from the definition of the enthalpy of formation. So enthalpy of formation is formation of 1 mole for elemental state. Elemental state of oxygen is O2 and carbon is carbon solid. From there, we have prepared CO. Now see this reaction from equation 1. If you are going from equation 1, okay, so C plus O2. So carbon required here reactant side. This is also reactant side. So same we are writing C plus O2. It is giving CO2, and here value is 393.5. And second one, CO plus half O2. This is there. So CO, which direction we required? Janab, can you please tell me? In the step from 2, CO is given reactant side. In the required reaction, it is which side? Product side. Yes,
Yes, sir.
product side. So what we need to do?
Yes, sir. Product side.
So we need to reverse the equation. So everything will reverse. Sign of the value will revert. So here see, this I am writing CO2. Then the art is reversing. So it is giving CO plus half O2. And this value become that is plus 283.5. This. So what we are going to do here, you can see CO2 is right side, CO2 is left side, cancel out. So add these two equations. So if you are adding C plus O2, multiple step. O2 means what? This half O2, and this is one O2 is there. So it will be left half. How much? Half will left. 1 minus half, that is half left. So 1 by 2 O2, and it is giving CO. So if you add out, so this one. So now, so enthalpy of formation will be what? Delta H1 plus delta H2. This is what Hess law. According to, this is what going to be Hess law according to Hess law. So here see, enthalpy of formation they are asking H1 how much is there? minus 393.5. And here is the plus is there. In bracket also plus it will come. So 283.5. So add out, solve it. Solve how much is coming. Please solve.
Okay, sir.
Hmm.
Zero, zero, one, sir, 110 minus 110.
Minus 110. Okay. So it is coming minus
Yes.
110 kilojoule per mole is coming, because all the value are given in the kilojoule per mole. These are the kilojoule per mole. Okay. Why per mole?
Yes, sir.
Because only 1 mole product is forming. So correct option is option number B. So please make a note, and
Yes, sir.
remaining you will be able to study in the next class. Will be studying. Yes, na? So
Okay, sir.
thermodynamics means slowly study. Otherwise, the same day too much study means the confusion.
Yes, sir. Done, sir. Done.
So remaining part we will study in the next class, Janab, na? Yes?
Yes, sir.
Okay. Bye. Take care.
Yes, sir. Yes. Thank you, sir. Bye.